Hi, my name is Robert Yango. I'm an industrial systems engineering major and a minor in Chinese. In this project, I was focused on understanding and installing different hardware in the building. I learned a lot about Modbus communication, wiring diagrams, and HVAC systems. I was challenged most when I had to develop novel solutions with low-cost sensors.
Hello, my name is Ankita Krishnamurthy, and I'm a fourth-year industrial and systems engineering student with a minor in business at Ohio State, and I'm a student research assistant at CDME. I was primarily involved with the project management aspect and communicating with research faculty and industry partners from our external advisory panel. I also assisted with hardware setup, where I was able to learn a lot about the HVAC system and electrical and water metering in buildings such as this one. I found it really interesting to learn about the different components of energy consumption in buildings like this, because I think that a lot of companies can benefit from this data, and I think that they'll be able to find a lot of cost savings as well as ideas on how to reach their sustainability goals.
Hi, my name is Tu Fen. I'm a first-year PhD student in the Industrial and Systems Engineering program at OSU with a specialization in operations research. My role in this project was the student leader. I worked on gauge utilization, programming sensors, and creating a dashboard to house the data we collect. I learned a lot on hardware to support research on the Internet of Things and how to integrate data collected from different sensors and different brands, different communication protocols to one platform. It is great to be able to develop decision analysis applications and building management solutions with data analytics.
The goal of our project is to find low-cost methods to reduce energy usage in aging infrastructure. The problem with that is that it's difficult to understand how a building works when it is older. The older it is, the longer the history is of renovations or adjustments. It is also hard to find cost-effective methods to measure, implement, and control building energy usage on a tight budget. Today, most buildings that are too expensive to demolish or to renovate are left idle, bleeding money out of people's pockets. Renovation projects are often constrained by consulting people who want to implement the most expensive technologies, not necessarily the most useful. Our approach is novel because we're focused on scalable methods that can be implemented by any able-bodied person on a tight budget. Success of the project means that we'll produce publications of which sensors and energy-saving methods are the lowest hanging fruit for any building manager to implement. This will be measured by monitoring the energy usage before, during, and after the measures are put in. The primary risk is the time and money it takes to put in the sensors and the energy test measures. The project budget we had for a 112,000 square foot building was only $40,000 to pay for student workers, the hardware donated from the smart building team at Siemens, and everything else included. Our project midterm checks we designed for success were created by quarterly meetings with an industry advisory panel. We'd report our current progress, what we needed help with, accepted feedback, and opened the door for next steps. Lastly, our project success will be measured by the impact made by our publications on how low-cost smart building technology can impact the everyday person. Our team at CDME wanted to give a special thanks to Lindsay Johnson, Bob Greider, Caitlin Hawley, David Holloman, Ryan Newman, Rob Biro, and Aaron Daniels, as well as the team from FOD, Miss Aparna Dial, Luis Rodriguez, Ryan West, the Bird Polar Center, and the other project PIs and advisory members. We appreciate your guidance.
This is our holistic building data analytics dashboard using PDC TheWorks. On this dashboard, we aggregated data on energy consumption, indoor environment monitoring, and we created a novel method to digitalize the pressure gauges. We are bringing value to the research community by quantifying the effects of cost-saving methods to aging infrastructure. For example, a decision analysis with model formulation can help us answer questions on optimizing the trade-offs in retrofitting, remodeling, or management. Baseline parameters are collected with our low-cost sensors. We want decision makers to know the truth about individual impacts on the building. The dashboard provides data for decision makers to calculate their return on investment for measures such as covering the building skylights. The dashboard functions as a building health checkup with live data.